Okay, Algebra 2. On Friday we started this section, which is 6.1, and it was operations on functions. We talked about adding, subtracting, multiplying, dividing, but then we also talked just briefly about composition. Composition, yeah, I did spell that right. All right, and so composition is what we're going to finish this section out by doing today, because I think we have like 2 examples left maybe. But composition, so if we go to like example 4, I'm going to run through that one real quick again. They want us to do composition it kind of looks like fog and goth, where it's an open circle. Now keep in mind that if it's an open circle, that means composition, but if it's a closed circle like f dot g, this means you're multiplying them together. So they're entirely different. All right, so open circle, that's what that means. Or if you want to write this down right above it, this is right above it, or right on example 4. Sometimes they will write it in this notation where they'll put g like in parentheses inside of f, okay? So they'll write it like that, or they'll do g parentheses f of x. This means composition without the open circle, okay? Those 2 things mean exactly the same thing. All right, so when you're doing this, you want to first and foremost, like if x lives here, I want to do the g part to it first. So it's like you're working from the inside out. I want to do g first, then I want to do f to it, okay? So what I'm going to do is I'm looking in the g part, and I see my g's, and I'm going to start with all the x's, right? So we did this in the table, and we said we're going to start with 4, we're going to start with 5, and 13, and 12, right? 4, 5, 13, and 12, okay? Then if I take 4 and I plug it into g, I get 1, right? But I don't want to just stop there, because I want to take that 1 and I want to plug it into f, right? It's kind of like applying the sale and then applying the coupon afterward, right? So if I have something that's $4, after the sale it becomes $1. Okay, but then I still have a coupon to use. $1 is going to then turn into $12. This doesn't really make sense as far as money-wise, but $1 is going to transform into $12. So what was originally 4 became 1, and then 1 became 12. So 4 became $12. Okay, then if I start with 5, 5 went to 0, and 0 over here becomes 13, right? So 5 becomes 13. Okay, and we did it like that. Now they say if they switch and they want us to do g composed of f, now I'm looking at f first. So I'm looking at all these input values first. I'm looking at $1, $10, $0, and $9, right? And I'm plugging them into the f table. So we said 1 became 12, right? And if 1 becomes 12, then 12 becomes 10. So 1, what was started out as 1, became 10 afterward. It skipped over the 12 and it became 10. Okay. Now then if I look at 10, 10 becomes 11 here. $10 becomes $11. Then what does $11 transform into? Well, I don't have an 11 here or here or here or here. So we don't have a rule for 11, so that's why we ended up with no solution there, right? So this was our table for f composed of g and g composed of f, and that's what he looks like. So if we're given coordinate points, that's what we do. We do the 2 kind of table looking things. And it tells us what each like amount comes out to be, okay, after we're composing. Now, go to example 5. They want us to do f composed of g. So again, that's, if you like to write it in parentheses, it looks like this. And g composed of f looks like this, okay? But they don't give us coordinate points. They give us actually equations for them, okay? So, all right. This is my f function. This is a linear function. But then so is g. G is just 3x. That's a linear function as well, right? If I would graph those would be straight lines, right? So what they want us to do is they say f composed of g first, which, again, if you use parentheses, or they did brackets for some reason, don't let those brackets confuse you. It's just kind of like a second set of parentheses, right? So what they're wanting to do is, what this means is we're taking the g function. G is the inside function, and f is like the outside function, okay? So if f is the outside function, this is what goes on the outside. I'm taking this g function and I'm like stuffing it into f, right? But what he's going to do is he's going to go here and he's going to replace this x. So this x gets knocked out and the 3x goes in its spot, right? That's g getting shoved into the f function, right? So it was 2x minus 5, but instead of the x, I'm knocking that x out and I'm replacing it with that 3x. That 3x is going in there, right? Okay, and then all they did was these 2 can be multiplied together. That's what those parentheses are doing. So 6x minus 5. This is what f composed of g of x will look like. I'm taking the g function, stuffing it into f, and then simplifying. That's all I'm doing, okay? Then it says part B, state the domain and range. Wait. Let's do the other one first. So they want us to do now. They want us to do G composed of f of x. Just a little hint, it won't be exactly the same value, okay? So here we got 6x minus 5. We are not going to get 6x minus 5 over here. What we get, though, is so G composed of f. If you use parentheses, it looks like this. Now, the f function is the inside function and the G function is the outside function, okay? So let's see what that looks like. This guy, let me erase some stuff. This guy is my outside function. And then this is what's getting stuffed into here, right? That's going in. This goes into there, right? So this x that was here, we're going to knock him out. And what's going to happen is this stuff is going to fill in his spot, right? So it was originally 3 times x, right? Like x was originally that spot, 3x, okay? But now instead of that x, I'm going to put the f function, which was 2x minus 5, right? And that's what he will look like. I'm taking this f function and I'm stuffing it into this 3x, okay? So I'm going to distribute my 3 through. That's all I need to do. 3 times 2x is 6x. 3 times negative 5 is negative 15. This is what G composed of f of x is. Okay, this f function went into the G function. Okay, this went into the 3x, and there we end up with 6x minus 15. So altogether very different. All right, now this 6x minus 5, if we look at his output, he is also a linear function. If I were to graph him, I'd start at negative 5, 1, 2, 3, 4, 5, and I put a dot. And then this 6x means I'm going up 6 and over 1. So he looks like this. You don't have to graph this, but I'm just showing you, keep that in mind, okay? That's a linear function. And when they ask for domain and range, the domain is left and right. So will this function go to the left and to the right forever? Yeah, as he goes up and out, he'll go out as he goes up and down. So his domain will be all reals, okay? Now range is up and down. Will he go up and so he'll go left and right forever, but will he go up and down forever? Yes, he will. So range is going to be all real numbers as well. Okay, same thing over here. 6x minus 15 is also a linear function. He's just down at 15 first, and then I go up 6 and over 1. So he'll look like this. But he's still going to be a linear function, still going to have all reals for domain and range. Okay, so both functions, domain and range, all reals, all right? But that is f composed of g, g composed of f. You're taking the second one and you're sticking it into the first one, okay? Now, one more thing before we do this example down below here, okay? Let me show you how sometimes let me go to your homework assignment. The last 3 problems on your homework assignment look like this, okay? G composed of h of 0, okay? So let's show you how that works. I'm going to do this example up top here. Let's say we have, I'm going to use those same functions. Let's say I want you to find, let's go f composed of g of 1, let's say. Sure, f composed of g of 1, okay? And then let's go f composed of g of 5. And then let's do a different one. Let's do g composed of f of negative 1. Let's do that. Okay, so here's what we're going to do. Looking at this function, we don't have to, if we're plugging a number in, we don't have to stick like this entire function into this one. Here's how we do this, okay? They're actually giving us a value, like something that is $1. I am now plugging that $1 into the G function first, right? I plug that $1 into G and I see how much it is. Like G is like the sale value, okay? So after the sale, how much is that $1 worth, okay? So I look at G and I plug 1 into the G function. After the sale, it turns into $3, okay? So this value is $3, okay? G of 1 was actually $3. So now I want to take that $3 and I want to plug him into the F function. So I'm going to plug $3 into here, and what happens is 2 times 3 is 6, and 6 minus 5 is 1, okay? So that is going to become 1 after I do both of those, okay? So you work from the inside out again, all right? So let's do G of 5, okay? Here, the G function, I'm starting with $5. I want to know what the G is going to do to it, okay? So if I plug $5 into the G function, that's going to return it to be $15, okay? So now I'm looking at doing f of 15. I plugged 15 in, or 5 into G and it became 15. Now I'm going to do 15 into f. So I put 15 in here and 2 times 15 is 30, and 30 minus 5 is 25. So the whole answer is 25. Now keep in mind, 3 was the answer, or was part of the way to get to the answer of 1. 15 was part of the way to get to the answer 25, but you really only have one ultimate answer. It's the ending answer, right? So 1 was your answer to this problem, not 3. 3 got you there, but 1 is the ultimate final answer. 25 is the ultimate final answer to this one, not 15. 15 just got you to that point, okay? So now let's do this one. This is the last one. F of negative 1, okay? That means I'm plugging negative 1 into F first, not to G. G was what we used up here, but now I'm plugging negative 1 into F first, okay? So I switched like which one was my sale and which one was my coupon. I'm plugging negative 1 into the F function first. Negative 1 goes here, okay? 2 times negative 1 is negative 2, and then I want to subtract 5. So that becomes like negative 7. So this whole thing is negative 7. Now I want to figure out what G of negative 7 is, right? So I plug negative 7 into G. So this is 3 times negative 7, which is negative 21. So my final answer is negative 21. Okay, so there's a difference between finding F composed of G of X, like that's here. That's where you stick one equation into the other, like you're coming out with an equation. Or if they say do F composed of G of 1, like we did here, you're going to get a number as an answer, right? And you can just plug one into the other, okay? So hopefully that made sense. I know eventually we'll end up doing whiteboards with this type of stuff, and we'll just do like some rapid fire whiteboards. But you know, that's where we're at for now. Compositions of functions. Okay. All right. Now this is a story problem. This is the last problem. Story problem that has to do with why composition of functions is a good thing, or why we need to use it. Okay. So it says a movie theater charges $8.50 for each ticket. Okay. And they say X number of tickets. Okay. So I'm going to skip down here, and they say money earned on ticket sales is called T of X, okay? So what I'm going to do is I'm going to say T of X. It's kind of like F of X or G of X. It's just like your Y coordinate, Y equals, right? Okay, and if I'm charging $8.50 for each ticket, all I would need to do is take $8.50 times X to figure out how much money I made, right? Like if I sold one ticket, that would be $8.50. If I sold 2 tickets, that would be like $17. If I sold 3 tickets, you know, you keep multiplying by $8.50, etc., right? That's how you figure out what, you know, what you get, okay? All right, next thing says the manager wants to determine how much, I'm right here. The manager wants to determine how much the movie theater gets to keep of the ticket sales if they have to give the studios 75% of the money that they earn on the tickets, okay? So they have to give away 75%, okay? If the amount that they keep of each ticket is K of X, okay? So this is the amount that they keep, all right? Let's say they make X amount of money, right? What they want to do is they want to give away 75%, which means they're going to keep 25%. So after I figured out how much money I'm making off of like the ticket times 850, blah, 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 I'm going to take that amount times 0.25, and that's going to tell me how much money that the studio, or that the whatever we're talking about, the movie theater gets to keep, right? Okay, now, what they want to do is it says they want us to, which composite function? Do they give us choices? No, they don't give us choices. Okay, they want us to, we're going to write a composition function to determine the amount of money that the movie theater gets to keep. So here's the deal. Just hypothetically speaking, let's say we sell, I don't know, like 10 tickets, right? If I sell 10 tickets, then that means I have to plug 10 into here. Okay, 10 times 8.5 is $85. Then I would have to plug that number into here to figure out how much money I get to keep, right? Like whatever that is, 25% of, or 0.25 times 85. Okay, but rather than doing that, what I can do to make life easier is I can take this entire function right here, and I can shove it into there, and here's what it will look like. 0.25 times, instead of this x is getting deleted, right? And it's 8.50 times x here. Like this function got shoved into there. And now all I have to do is plug 85 in here and then calculate that whole bit, and it's all ready to go for me. okay? It's kind of like taking 85, plugging it into the top number, or not 85. Why did I use 85? 85, 10. I said 10 tickets, right? So rather than plugging 10 into the top and then plugging that amount into the bottom, I just plug 10 into the whole thing, and it will give me the amount of money that the movie theater gets to keep, okay? So that's a composition function, all right? And because we took t of x and plugged it into here, that function is represented by k parentheses t of x. It's like we took this stuff and shoved it in for this x right here, okay? So this is k of t of x is what it's called, or k composed of t of x, and that is what this junk is, okay? All right, so a little bit confusing, but there's a use for it because then it allows us to kind of like skip steps later on, right? Okay, so they had us do that in 4 steps. I don't know why. But anyway, there's that, okay? All right, you guys have problems that we listed out on Friday, so hopefully you've got a good start on those. I'm going to add these 3, 4, 8, 13. Sorry. So do those for tomorrow, and then we'll go over any questions that you have tomorrow and talk through some of those, okay? There you go.